All right. Good morning. Happy Friday. Maybe sad Friday because it's our last time, our last class today. So well done. Let's see here. Great job. I know, time really does fly. It's crazy. So it's our last class. I try to mix up my emojis for my classes. I don't know. There was one with like a little teardrop and a happy face, which I thought was pretty funny for one of my classes, but I don't know. I'm always sad at the end of the term when I don't get to, I haven't really been seeing you guys, but I don't know. I feel like we've gotten to know each other a little bit. Okay, so I think we'll just get right into what to expect for the final exam. In terms of kind of the format, it'll be similar to, so I'm trying to think if there was anything that I wanted to point out before I get right into it, but here we go. Final exam review, more like overview. And just so you know what to expect. There is going to be linear regression on it. Just one question, but of course it's going to be one of those multi-part questions. And so I'll be using similar questions to the assignments as you've probably noticed on the tests. And my apologies, I am marking your long answers, but it's been an insane week. So, and I'm sure you can understand that. And well, they closed on Monday night, but a lot of you did them over the weekend. So I'm sure you're like, hey, what happened? So I am working on them, but it's been crazy. And so don't worry, they're coming. Right. It'll be the same format as the tests. Okay. Let's see here. So kind of post it on Moodle. And you submit most of your answers electronically. Submit most answers electronically, of course. Okay. But then you'll also submit written work. I think I'll do 2 questions. Submit written work. I'm going to say for 2 questions. I haven't quite decided. As you know, our final exam isn't until December 17th. Okay, so our final exam, I'll put it here. December 17th from 9 to 12. Okay. Highlight that. Okay. So it's a ways off, and I know you've got other stuff going on until then. But in terms of review, what you'll want to focus on are, of course, the assignments as well as the tests. And they should all be available for practice. So now that once they close, then you can go back in and you can practice them, and you can use them for ungraded practice. So that's what's really nice about the system. Okay. So, oops. Use the assignments or the assignment questions for review, hopefully you've noticed that the test questions are very similar to the assignment questions because that's how I choose them. I want them to be similar, so I'm really kind of focusing your studies. And so use the assignment questions for review and use the assignment and test questions. I think they should be open for, all are open for ungraded practice after they close. Even if it hasn't closed yet, you should be okay because it should just keep your highest mark. If it doesn't, if you are going into practice before it closes, then I would say take a screenshot just in case. It just has a record of your highest grade. If you think you're just going to be focusing on a couple of questions, you don't want to have a bad grade going in. So just take a screenshot and just have it in case something happens. And then if something happens, I'm not sure what the setup is because I couldn't find it in the system. Then I can just go back and change it if you have a record. So that's what I encourage you to do if you're doing it before it closes. After it closes, they'll be open for ungraded practice and you're free to do whatever you want in there, okay? So you're gonna use the assignment questions and the test questions, of course, for review, okay? And which assignments are you gonna focus on? Well, so I wanna tell you kind of the number of questions to expect, and I'm gonna be referring to the assignment numbers, okay? And so, the exam will have, so it's kind of tricky because some of these questions are going to be, quick multiple choice questions. And then some of them are going to be, those full blown hypothesis tests or confidence interval questions, right? And so it's a little bit hard to say, oh, there's going to be 4 questions. Well, that could be like 100 parts pretty easily, actually. And so that's not really helpful, but I want to kind of help you along by saying, okay, there's going to be 3 questions. Yeah, so the number of questions is kind of irrelevant. And so there, I want to show you kind of how many questions from each assignment to expect. And then that'll give you a better idea of what's going on there. Okay, and so the exam will cover the following assignment material. Just because I feel like that's the best way to do it. So I've combined assignment 1 and 2, which is going way back. What are some of the things we can do here? Well, we talked about what type of variables do we have, right? So variable types. Is this a numerical variable or is it a categorical variable? And is it a response variable or is it an explanatory variable, right? And so numerical, categorical, explanatory, or the response. Sorry, I'm gonna get kind of cut off there. Numerical / categorical. Okay. What else? Appropriate graphics. So if I have a numerical variable, what should I be doing? I should be using a histogram. If I have a categorical variable, I can make a bar chart, most likely, right? And so just identifying, okay, based off of the variable type, then what's the appropriate graph? Selecting appropriate graphs. Right, based off of the data. These are all pretty short answer questions, you know, quick multiple choice questions. We also talked about the difference between an experiment versus an observational study. What else are some key things? Oh yeah, numerical summaries, right? So we talked about, because I think, yeah, numerical studies, sorry, measurements. I don't know why I said studies. Well, I do. It says right here, and I read that. Measures of center, which is the mean or the median. I'm going to cut the mode, but that's an option too. Measures of spread. The standard deviation or the interquartile range. Identifying outliers, the 1.5 IQR rule for outliers. Right. How many of these are there going to be? There are going to be 3 questions. And they're going to be short, if that helps you along anything. Okay. So just kind of 3 quick-ish questions. Okay. And then there's going to be one from assignment 3, which was when we started probability, and another one from assignment 4, which is kind of the a little bit more advanced probability, so conditional probability. So assignment 3, there's going to be ×1 question. Assignment 3, I want to say kind of basic probability terminology. Basic probability terminology. Probability rules, right? Things like the complement and I can only think of the complement right now. Oh, the union, the intersection, right? And so basic probability rules. Yeah. And I'll leave it there. Okay. Just kind of the general addition rule, the checking for independence. Okay, so the general addition rule. Independence. Pretty sure those are all in there. Okay. Assignment 4, like I said, 1 question from assignment 4. And that's when we got into conditional probabilities and tree diagrams. Conditional probabilities. And I feel like that's where the tree diagrams were. I'm just going off of memory, so can't quite remember, but I'm pretty sure. So I'll leave it at that. So for probability, 2 questions from probability, and that'll be plenty. Okay. And okay, so from assignment 5 is on Z-scores. Like I said, I'm trying to remember what all the assignments were about. I have them kind of laid out in my mind, but there's going to be one question from assignment 5, and it was on the normal distribution. The normal distribution. So that's where we introduce things like the Z table and Z scores, right? And so Z tables to find probabilities. Why did we do that? Kind of in hindsight, why would we learn that? Well, we needed it later, right? Because the p-values, especially for proportions, are just the areas in the tails, right? And so we had to develop those skills. And so now when you go back, I think you'll find that, oh, this is pretty easy compared to what we have seen, right? At the time, it was probably a lot, right? Kind of overwhelming. But my hope is that now when you go back and you review these, I think what you'll find is, oh, why was this so hard? That's what I'm hoping, but we'll see. You can let me know. Okay, so the normal distribution, we talked about Z scores, the Z table to find probabilities, or maybe find probabilities or cutoffs, right? So you either have some value that you want to find the probability associated with, or you have some probability and you want to find the value that it's associated with, right? That it was a two-way street. Okay, so you have an X and you convert it to a Z and then you find a probability, or you go the other way, you have a probability, you have to convert it to a Z score and then convert it to an X. Right, so it's kind of this gateway situation between the Z. So here, probability, or you can go the other way, from a probability to a Z to an X. So there's one question on there, and it'll likely be just a couple of parts, you know, A, B, C type of situation. Okay, and then we got into assignment 6. Assignment 6 was on the other distributions. So we talked about the binomial, we focused on the binomial, and then we also introduced the Poisson, and I think we talked about the geometric briefly as well. I am going to tell you to focus on the binomial, but I'll put it on here, ×1 question. And I'll say here, it's going to be binomial. Right. But some of the things we talked about was the binomial to calculate probabilities. And there were assumptions here, right? With assumptions. Right, so use the binomial distribution to find probabilities of things happening. And there were some tricks that we had up our sleeves, right? If we want at least 1, then usually we just take 1 minus the probability of 0, for example, that type of thing. So worth reviewing there. But the binomial is the one to focus on. And we also had the normal approximation to the binomial. Normal approximation to the binomial. Okay. We also talked about the geometric and the Poisson. let's ignore those and just focus on the binomial. Assignments 7 and 8 and 9 were all about proportions. Now that's where we introduced ideas like the confidence interval and hypothesis testing, and we introduced it using one sample proportion, right? So we spent a lot of time there, but we were actually developing, so it felt like we focused on one sample proportion a lot. But what we were actually working on were the skills for confidence intervals and hypothesis testing, because then what you've hopefully noticed is we can take those skills and they apply in all the other scenarios, right? And so I'm going to lump assignment 7, 8, and 9 into one thing because we were, really working through our skills there. And so assignment 7 and assignment 8 and assignment 9, we're going to have 2 questions from that region. 2 questions, right? And so here we talked about one sample proportion, confidence interval, and hypothesis testing. And maybe I should say, sorry, I'm going to say assumptions. Assumptions, confidence interval, and hypothesis testing, right? There's a lot in there. And then we talked about, one sample proportion, and then we moved to comparing 2 sample proportions, right? And so 2 sample proportions. Again, we checked the assumptions, the confidence interval, and the hypothesis test. And I'm also going to sneak in the chi-squared, right? We finished with the chi-squared, which allows us to compare more than 2 categories, right? If I have 2 sample proportions, really what I have is I have proportions from 2 categories. So now I can extend it to more than 2 categories and use the chi-squared. So the chi-squared test, we checked the assumptions, but they're not as crazy as the 1 sample and 2 sample proportion questions, right? And we checked the assumptions. And then we did goodness of fit test. But we also did a test of independence, right? And so the goodness of fit test is if you only have one categorical variable with more than 2 categories, okay? And maybe what I'll do is I'll do a little subsection here. How can I? Goodness of fit test. How about that? One categorical variable with more than 2 categories. And then we did a test of independence. Which was for a 2-way table, right? So now I have 2 categorical variables, and one of them will have more than 2 categories. The other one is allowed to have 2 categories, but one is going to have, 3 or 4 categories, which is when we test 2 categorical variables. Okay. So remember, you had to do a 2 sample proportions question for the long answer on test 2. So am I going to make you do it again? No, I only need to see you do it once, right? It might be, you know, one of the ones where you don't have to hand in your work, but I will focus on hypothesis testing and confidence interval questions for you to hand in your work. So that's just something to keep in mind. Okay. I'm not going to do anything explicitly for assignment 10 because that was just to introduce you to the difference between a proportion question and a means question, right? Because that's really important that we develop that skill of identifying what type of variable we're talking about, right? And so for assignment 10, no questions explicitly. Okay. For assignment 11 and 12, I'm going to do 2 questions. Okay. What was involved on assignment 11 and 12, I'm lumping those together because those are the 1 sample and the 2 sample means questions. And if I have 2 sample means, they can be related or they could not be related, right? So they could be paired or they could not be paired. They could be independent. Okay. So we had 1 sample mean. We talked about the assumptions. What's nice about the assumptions for means questions is that you really just need to make sure that you have a large enough sample, right? Your sample size is more than 30 so that the central limit theorem applies. And did you have a randomly selected sample, right? Are your observations reasonably independent? Can you assume that they're independent? So the 1 sample mean, you check the assumptions, and we talked about hypothesis testing and confidence intervals for 1 sample mean. Then we moved on to paired samples, which is 2 samples, but they're paired, right? We also checked the assumptions. We did a confidence interval. We did a hypothesis test. I'm noticing I'm doing these in different orders. There's no hidden information there. It's just whatever feels right when I write it. So don't worry, there's no rhyme or reason here. We did both. Okay. And then we talked about 2 independent samples. We checked the assumptions, which again is just, do we have a randomly selected samples for both of these samples, because we need them all to be independent, both within the groups and against the groups, because otherwise they're not 2 independent samples. And do we have large enough sample sizes so that we can apply the t-test safely, which will be true, but right. And so the assumptions, confidence intervals, and hypothesis testing. Okay. These were all using the t-table, right? So here we're using the t-table for our p-values. Yeah. T-table, whereas for the chi-squared test, we use the chi-squared table for our p-values. And for the proportions, we use the z-table. Right, that all hinges on what test statistic you calculate. If you calculate a z, you have to use the Z table. If you calculate a chi-squared, you have to use the chi-squared table. If you calculate a t, you have to use the t table. Okay. All right, great. Assignment 13 was on ANOVAs, and there's going to be one question there. Assignment 13 is really small, so that should help you out a little bit. Assignment 13 times one question, and that was for ANOVAs. Just the assumptions, but it's just as long as we have more than two means that we want to compare. So is there any sort of difference among these means? And then we only do a hypothesis test here. And for the chi-squared test, these are only hypothesis tests. Forgot to add that there. Because we don't do confidence intervals for chi-squareds. We only do them for proportions and for means. As far as we've gone, we can build confidence intervals as long as we have an estimate from our sample and the standard error of the estimate. You might have noticed in the regression output, for example, then it gives you the standard error of the coefficients. So you can build confidence intervals for each of those coefficients because those are all estimates. But we'll leave that for well, Stat 240 probably, if you're coming with me to Stat 240. Which I saw a lot of familiar names on the list, so that'll be really good. Awesome. Yeah, see you there. So we need to leave. Well, there's lots and lots of things we can do there. So we've got options. All right. So we can only do so much here in Stat 230. All right. It feels like a pretty long list so far. And then the final assignment, assignment 14, because I can't remember if there was anything else I was going to say here for the ANOVAs. I think not. So assignment 14, there's going to be one question. And it is going to be a regression question. We're going to do, of course, a simple linear regression question. The simple part means that there's only one value, one predictor or one explanatory variable. One explanatory variable. I snuck one in there, a multiple regression at the very, very, very end. And there's one on assignment 14. So obviously that's not going to be the question that you have to work on. But I think what you'll see is that it's pretty straightforward stuff. You just have one more X or multiple X's, but you just add them into your model the same way that you do the other explanatory variable. Okay. So it's going to be a regression question. What are some of the things that we've done there? Well, we talked about the correlation is kind of where we usually start our discussion. We talked about R squared. We talked about y hat is B naught plus B1x, right? And we talked about predicting values of y given some value of x, given a value of x. Okay. What else? Oh yeah, interpreting the slope. Interpret the slope and the intercept. Okay. And I'm sure we talked about some other things there, but those are the key things, right? Building your regression line and then using it to predict values, but also interpreting the slope and the intercept. And then if you have some R squared, remember that's the proportion of variability or the percentage of variability in Y that's explained by the least squares regression line on X. It's a long wordy thing, but that's what makes it easy to pick out, right? As soon as you see proportion or percentage of variation, then your mind goes R squared and then you're off to the races. Correlation is the square root of R squared, or R squared is the correlation squared, right? And so there's a relationship there. I'm being funny because the correlation measures the strength and the direction of a linear relationship, right? So, all right. I feel like that's my whole list. Okay. Be prepared to submit written work for 2 of these questions, just like you did for test 2. So that's good. Yeah, are there any questions? All good. Wow. Feeling overwhelmed yet? Hopefully not underwhelmed. What? That's all we covered? I don't know. Feels like a lot. Okay. Oh, the other yeah, the other long question. I'll never tell. It's going to be a hypothesis testing confidence interval one. I'm leaning towards only doing 1 written question, but we'll see. Because I haven't seen you. So the ones that I'm leaning towards are, of course, these 2 questions from assignment 11 and 12, because I haven't seen you do any of these by hand, right? So, and I want to see and check in what that looks like. So, but I'm not committing. I'm just saying that that's something to expect. Yeah. Okay. Well, if you have any questions, I'll stick around. But otherwise, I want to thank you for a really nice term and thank you for working so hard. And good luck with your final exams. And I'll stop this recording here. See ya. That was for the recording.